multiply both sides by x, and we would get x times y equals 1. That was kind of a silly one to do implicitly, but today we're going to learn how to take the derivative when x and y are on the same side together, because sometimes you can't get y by itself. All right, and so this is definitely something that shows up on the AP exam, and it's just kind of a cool new way to take derivatives. Who's excited? All right, so here's kind of my little rule. I have steps for you in a minute, but this is my overall rules. Normally, when we take the derivative, we do it with respect to x. So when we take the derivative, we just do our normal rules. So on these problems, when you differentiate, or when you take the derivative of x, you do nothing new. You proceed as usual. You might need to use a chain rule, you might need to use product rule, you might need to use power rule, but you're just going to take the derivative as normal. But when you differentiate with y, you have to say, hey, I'm doing this with respect to x. I'm going to show you what that means in a second. Basically, you have to multiply by the derivative with respect to x every time. And it's kind of weird at first, but then once you get the hang of it, it's not so bad. We have to show that we're doing it with respect to x every time, right? Well, we do by just putting dy over dx on the outside, right? Here, let me just do this other one right now. When I say y equals 4x squared, let's do that one. When I take the derivative, we kind of don't think about this side because we always just say y prime. But really, when I'm taking the derivative, if I want to think about taking the derivative of this side, I'm going to take the derivative of dy with respect to dx, right? That's where dy over dx comes from. When I take the derivative of this side, bring the 2 down, 4 times 2 is 8x. We don't put anything over here, and the reason why is because if we wanted to show that we were taking the derivative of x with respect to x, do you agree that's always just going to equal 1? So that's why we don't ever talk about that side, because it's with respect to x already. But when you take the derivative of y, you have to show that you're doing dy over dx. We don't think about that usually because y is by itself over here. But in other problems, let's look at one and see if we can make sense of this, right? So what if I made you take the derivative of this problem? X squared minus y squared equals 16. This problem, it would be hard to get y by itself. You would actually end up with two equations because you'd have to take the square root and you'd get plus or minus. And that's kind of weird to do. Like, how do you take the derivative of a plus or minus equation at the same time? So this is a problem where implicit differentiation is kind of the way that you have to do the derivative here. So we're going to go through and we're going to take the derivative of x, just like normal. We're going to also take the derivative of y, but anytime you take the derivative of y, you have to say, oh, I'm doing that with respect to x. You have to put in a dy dx. That's kind of the extra rule here. So I'm just going to take the derivative of everything. When I take the derivative of x squared, what do I get? 2x. Nothing's changed. Minus, what would the derivative of y squared be? Yeah, like I'm just going to, the same rule, power rule, I'm going to bring the 2 down, subtract 1 from y. But because we're doing this with respect to x, anytime you take the derivative of y, you have to multiply by dy over dx to show, hey, this is really the derivative of y, but I'm doing it with respect to x. Equals, what's the derivative of 16? Just 0. Now the only other thing we have to do is some algebra. We want to know what is dy dx. So when you do this, you now just have to get dy dx by itself. So you just need to solve for dy dx. And every time you do the derivative, you're going to have a dy dx in there. Sometimes more than one dy dx if there's more than one y in the problem. So we have to just do a little algebra here. So do you agree I could just subtract 2x over to this side? I'd get negative 2y dy dx equals negative 2x. And to solve for dy over dx, I could divide by negative 2y, and I would get that the derivative to just x over y. Notice that my derivative now has an x and a y in it, but it's still the same thing. It still represents the slope of that problem, but now you need an x and a y to plug in there to find the slope. How do you feel about that? That's kind of cool, huh? If you do some of these problems. There's one of these on the AP exam from 2012. Let me tell you, it was a multiple choice problem, and it was ridiculous, and I did it 3 times before I got the right answer because I just kept making stupid little, like, arithmetic mistakes. And I was like, I would just have been so mad if I was taking a test on this and I couldn't get the right answer to work out. Because I knew how to do it. It was just all the arithmetic. And that's what, tomorrow we're going to do those types of questions that get a little crazy. Like the second implicit derivative, they get a little crazy. But it's always on the AP.
So you have to have like x over y.
Yeah, so then you have to take the derivative again. So you have to do the quotient rule and, yeah, it's more crazy.
That's like 5.
I think I wrote some directions here. If you feel like you kind of got this, you don't necessarily have to write these all down. But if you're a step kind of person and you feel like you're a little confused, you might want to write it down. But I wrote step 1, you're always going to differentiate both sides with respect to x. Right? That means when you take the derivative of y, you put a dy over dx there. And then the second step is you've got to solve for dy over dx. So I put collect all terms with dy dx on one side. So get your dy dx stuff on one side, everything without a dy dx on the other side. I have no notes for these. I'm just winging it. I have day 2, but I don't have day 1. That's okay. Oh, look, here it is. I knew it were here somewhere. And then we're going to do one in a minute that's a little bit harder. Like if you have more than one dy dx, you have to factor out dy dx and then solve for it. And then tomorrow we get to talk about the second derivative. So if you're finding the second derivative, then you have to substitute back in dy dx later. But that's for tomorrow. So we'll write day 2 next to this. Don't have to worry about that today. This morning Parker was spinning around in my chair, and I said, "Stop spinning around my chair. How many times do I have to say that?" And he said, "Don't answer that question, right?" And I said, "Yes, don't answer that question." See, he's learning. I need to change what I say. Like instead of asking him the question, I should say, "I only need to tell you that one time," but I don't ask him that. I don't say it that way. So if you get stuck today on these, my advice is 1, go back and look at your examples, but 2, go back and look at these steps because it kind of helps you get started if you kind of get overwhelmed of where to start. And maybe I'll read this as like a double page for a minute as we're doing it. So the first one was kind of easy. This one, a little bit crazier. I don't know. It's probably kind of big. 1, 2, 3. I used 4 lines. 5 lines if you count the problem. All right, so we're going to go through and take the derivative. Kimberly pointed out, do I need to do the product rule for x times y? Yes, x and y are 2 functions multiplied together, so we have to do the product rule in there as we're doing that. And when you take the derivative of y, you have to put dy dx, and that's the big thing that people forget. All right, so I'm just going to go through and take the derivative. The derivative of x cubed is 3x squared. Now watch your signs here, especially because that's a minus x. I'm just going to keep like negative x as my first term there. So when I do the product rule and I take the derivative of negative x, you agree that that's just going to be negative 1 times y. So that's just going to be negative y. Normally in the product rule we add, right? But since that's a negative, do you agree that's going to be minus? You okay if I do it like that? So now I'm going to leave the x, and what would the derivative of y be? Just 1, but what else do I have to put? dy dx. So you put a 1 there, but it's not really necessary, so I'm just going to put dy dx to show I took the derivative of y with respect to x. So right there, that's the product rule here.
So every time you do y, you have to do.
Every time you take the derivative of y. Like on this part, we didn't take the derivative of y, we took the derivative of x, so that's why y just got to come down. But if you take the derivative of y, you have to put dy dx next to it. So when I do the derivative of y squared, what am I going to get? 2y dy dx. And don't forget you're taking the derivative of the other side. Another common mistake is people just leave that 4 over there, but we're taking the derivative of 4, which happens to just be 0 again. You with me on that? That's the calculus part. Now it's kind of just the algebra part. We need to solve for dy dx, so I'm going to take the stuff without dy dx and move it to the other side. So that would leave me with negative x dy dx plus 2y dy dx. And eventually you'll probably do this stuff all at once, but... And I like my numbers to be positive, so I tend to switch them around, but it's up to you. It's however you want to write it. Like, I'm going to subtract 3x squared and add y, so I'm going to write that as y minus 3x squared, which is the same as negative 3x squared plus y. And since I need to get dy dx by itself, do you agree that I could factor out, and that's what step 3 over there is, factor out dy dx, and I'd be left with negative x plus 2y equals y minus 3x squared. And usually when I do this problem, I factor it out at the same time as I'm moving stuff over because I know I want dy dx by itself. And if I want to solve for dy dx, how am I going to move that over? I'm just going to divide it over, and I'm just going to get this lovely fraction derivative as y minus 3x squared. And again, it doesn't matter how you write it, but since I wrote this one positive, I'm going to write that as 2y minus x, which is the same as negative x plus 2y. And that would be my derivative. You may.
First of all, is there any way that we'll ever split up like the dy and x and just have a dy and move a dx separately?
When we talk about differentials and differential equations, we do split up dy dx, but not right now.
Are we always going to take dy dx as y or
With like y prime, you mean? Or like... This is really just the way we write derivative, right? Like most of the time you guys write f prime of x or y prime because it's just easier. This means the same thing. I like using dy dx in this case because you have to put it in the problem. Technically, if you change this to y prime, it's okay, right? Or f prime of x. We don't usually plug in anything else, right? What if they gave you a problem where they said the derivative equals 7? Would that mean dy dx equals 7? So you could replace it with an actual number if depending on how the problem was worded. You with me on that? Something else we could say, I think it's maybe in here, but what if I now asked you to find the derivative? If I said, what is the derivative at the point 1, 2, do you agree now that you need both the x and the y to plug in there to find your derivative? Like no longer could you just plug x in to find your slope. You need both x and y, you plug it in, and you just get still a number answer. Okay? Maybe? Let's do it. Whoa, that's gigantic. Oh look, we can do it this way. We'll actually plug it in. Find the equation of the tangent and the normal lines, oh my goodness, how much fun could this be, of f at the indicated points. So again, when you see x and y in an equation, you have to start thinking implicit differentiation. On the AP test, it's definitely not going to say, hey, use implicit here. They want you to recognize it. On my test, it's probably not going to say use implicit. You got to recognize when you see x and y together. This one I threw in something different here besides the fact that we're actually finding the tangent line. Instead of equaling a number, we're actually equaling 2xy over here. So how are you going to take the derivative of 2xy? You're going to have to use the product rule again, okay? So again, go through, anytime you take the derivative of y, put dy dx. So I'm just going to kind of do it too, and we'll see if we agree on the derivative before we go any further. It's not so bad when it's just addition here. Don't forget dy dx. But on the other side, you have to do the product rule. And again, for me, I'm going to group 2x together as like the first one, and then y as the second one. That way I don't have to think about 3 different functions there. So that would just be 2y plus, leave the first one alone, and the derivative of y is still 1, but I have to put dy dx. You with me on that? Sometimes your answers might differ a little bit in terms of negatives, but it should work out that if you like factor out a negative, you could make it match what the back of the book has, because it depends on which way you do this. Like for me, I always take my dy dx and move them over here, and move the other numbers to the other side. And if you subtract this over here, your signs are going to be opposite of mine, but it would still work out. But I kind of just do this all at once, and you tell me how, if this makes sense to you. Like when I'm going to subtract this over, but at the same time, I know that I'm going to pull the dy dx out of it, so that leaves me with 3y squared minus 2x, because I moved that over. I'm going to subtract that over that way, so then I get 2y minus 3x squared. You don't have to do it all in one step. I was just kind of showing you that I
That's the other step. Why do we do 2x instead of dy dx instead of 2y?
Because I'm taking, the only time I put dy dx is when I'm taking the derivative of y itself. So on this one, I took the derivative of x, right? 2x, the derivative of that would just be 1. Oh, sorry. It would just be 2. And then I leave y alone. I don't do anything with it. But on this one, I left 2x alone, and I took the derivative of y. The derivative of y is just 1. And anytime you take the derivative of y, you have to put the dy dx with it. Does that make sense? Like, you don't necessarily put it when you see a y. You put it when you take the derivative of y. Okay? Other questions on this? So then to solve this, I'm just going to divide that over, and I think you should get some version of this. 2y minus 3x squared over 3y squared minus 2x. And again, if they ask you to just define the derivative, you're done. But this one, they ask you to actually find the equation of the tangent line. So remember, to find a tangent line, you need a point, which they give us, and you need a slope. To find the slope, you have to plug in both x and y. This one's easy because it's 1 and 1, but sometimes it's really easy to mix up your x and y because they're mixed up in here. So just be really careful with that. It's really annoying when that happens. That might have been one of my mistakes on that AP exam, because I mixed up my x and my y when I was doing this. But since it's 1, it's really nice, because that's just going to be 2 minus 3 over 3 minus 2, which happens to just be negative 1. If you know your point and you know your slope, you should be able to write your lines, right? Tangent line would be y minus 1 equals negative 1 times x minus 1. And how do we write normal lines again? So what would the opposite reciprocal of negative 1 be? Positive 1. So this is tangent. This is normal. It would be y minus 1 equals 1 times x minus 1. And again, you don't have to simplify it. I think I have another one that we're going to do on the computer. I'm so excited for this. I know. I'm doing it. I have it all ready for all my classes now. I'm trying to get prepared for these evaluations. Because I figure if they come and evaluate me and we've never done it before, and you guys are like, wow, we've never done it before. That won't look good. But like, as long as we've done it. No, I'm really going to try to do it more. It's just time consuming. So let's, you have to work this out anyway. So you can start working it out. And then you get to just buzz in with an answer, and I'll show you how to log in. make sure I started this class. See, this other annoying thing about it is you have to start a class, which I did already. And then I have to start a question. Stop it before starting a new one. How do I do that? Just hold the power button in at the top. You want your favorite? What are you talking about? We're not even gonna be able to do this, kids. Why does it say another assessment has already been started? Like, hold on, don't do anything yet.
Oh, should I turn it
Turn it back off. See, this is annoying. This is why things are ridiculous. It's supposed to be a quick and easy way to assess students' learning. It'd be quicker for me to just come around and check the paper.
Nothing a little smart. You know, it's not really that smart.
Okay. Now, press power and hold it in, and you want to join Dixon. So it should say join a class, or it might already say join Dixon.
Not available. Here.
Are you kidding?
Join
Yeah, mine said join Dixon.
No, I said join Dixon.
It says not.
Oh.
Try again. Try to join. Turn it off and turn it back on if it says not available. And then if you get join Dixon and it says ID, this is your number. Find your number that corresponds to your name and hit enter, and it should say. Why does Katie's work?
Mine works.
It's because I'm the best. Get there.
They're just,
Find the class.
they're just,
Quiet.
Too ridiculous. I'm gonna find it.
It works.
They're not available.
Oh, I got it. So I just press one.
Here, you just work.
yeah, mine works.
Who else has one that works?
Mine doesn't work.
There you go. You're ready for ID?
The little stick speaks, they're pretty
So
awesome.
just enter in your number. Your number one. Alright, now I'm trying to find it.
How do we answer?
I put on the one that is not available, I put search for class, and then it found Dixon, and then it let me join it. So that might be the way that we have to do it. So then hold on, it should say number one next to it, but let me make sure everyone gets logged in first. And then you're gonna hit A, B, C, or D, or 1, 2, 3, 4 to log in twice. But hold on, I gotta make sure everyone has their ID first. Imagine how fun this is if you just
So we know. And they all just, you're like, look, here's a graph of all the answers, and a third of you put 0.
Oh, look, that's right. I turned it off. Is everybody in now?
Yep.
Everybody have their number? This is the number you'll always be, but I'll save it for us the first 2 times. But maybe you can remember what number you are. Rachel has 2 numbers, so that. All right. So now once you get logged in and it says your name, it should say number 1 next to it because this is our first question, and you should hit 1, 2, 3, or 4, A, B, C, or D, for your answer. Yeah, I think you have to enter twice because you have to enter it and then you can change your answer. And then I can look and see who hasn't answered yet. So when we were faster at this, then I can be like, who hasn't answered yet? 5 of 9 students have answered. So I think that, like, it's review. That means you're good, I think. Because see, look, I can even put who hasn't finished.
Come on, Neil, step it up.
Or do us.
Is it going to show you everyone our answers?
No, I can go in and look at your answers. Like, I can show a graph. Like, after we do this a while, like, at the end of the chapter, I can go in and see, like, how many you got right over the whole chapter or each one. And it keeps
And that
it
can be
tally.
like a test grade.
And it could be like a test grade. Or
It's really good.
not a test grade. But
And what
Bonus,
is it so bad?
bonus that counts as test
Got it.
if it's below passing, it shows me red score when I go in. Like, right next to your IDs, like, I cut and pasted that. It shows the percentage of how many you got right. And it's like,
Well, I'm 100%, so.
give a dash
I'm
right now.
that confident that my answer is right.
Let's see here.
Yeah, you can never be sure.
It's like, yeah, no,
If
no,
I'm
answer.
wrong,
It's
Sean's
like,
going down with me.
we'll start out with zeros. And we'll have to take our way up to the bottom. It's like,
And
start out with a 0.
class, her grades are
Yeah,
I didn't, I knew you did have that.
That's funny. Well, when people like with participation, I did 10 points. So I just do that's 10, 10, 10, 10, 10, and I just hit the arrow. But sometimes someone gets 101, and then the next person gets a 0, because the one goes on the one before. And so when I was finalizing grades, like some people had like 120%. What? So then I had to go back and realize that someone had 101 and someone had a 0, and I had to fix it. But then in the hallway, Mr. Henderson was talking about one of his students, and he said, he has a 1,200% on one assignment, but he still has an F. So, and I just cracked up laughing. I was like, that's hilarious, or kind of sad. So that's really funny. Like he and Mr.
You can have a 1,200% and still have an F.
Mr. Stewart didn't notice because he saw the F. So like that's what I did. Like I just looked at grades and I was like, everyone's grade seems reasonable from what I know their grades are. But so like he had an F, and so Mr. Stewart didn't notice that he had like a 1,200% on one assignment.
You know that guy can feel good though.
All students have finished, so let's see how we answered. Everyone got it right, and so this proves I taught you something today. So then, like, if this would have been bad, and then I'm like, oh, we better go back and learn it again.
So on the day of evaluation, we should all put in the wrong answer.
No, this is good. Because if it's bad, I have to have another example. So. It would show like a little slice of 1 out of 9, so it would say what 8 out of 9 would be like.
I got it right.
All right, see, I don't even need to do it now because we all got it right.
All right. To the homework.
To the homework.
You can have another example.
No, because I was confident you were going to be right.
Actually, I like it.
So then you can just power them down. If you just hit power, it'll automatically log you off, so don't worry about someone else taking questions for you.
And getting them wrong.
In Ms. Vice class, people enter the wrong ID on purpose.
Mine's not letting me turn it off.
Just hold it down.
Oh, you have to hold it. You just said push.
Well, I was holding it and it wasn't working.
Let's see, there's annoying. You're gonna have to go that's not again.
You should get like little baskets.
I need a little like Velcro pouch or something.
To wear? Oh, and you can look into
No,
the hair.
no.
Except for the poor kids.
You know, you
That's
can
what
get
Nathan
like a
said.
bandolier.
Nathan said I needed to get some kind of pouch to carry that whole thing around the room.
You need to get like a bandolier and just have like keep your shot at shelf or something. That was pretty intense. No one really thinks we're good.
But anyway, my goal is to do that at least once a lesson to see if you kind of get the idea, so I know if it seems like we're good for homework. That's the point of these, if they work.
No one got it right.
I wish I could keep them. And if no one, well, like if the majority of the class gets it right, then I can say, oh, it seems like we got it, but maybe I need to check individually with an example. But like if everyone got it wrong, I'm like, okay, we need to fix this before we go homework.
No, so I was gonna ask for something early, but you know, that failed. Well, it's okay. Rachel, are you halfway through the short comments? Yes.
Like in college algebra, we did it yesterday.